This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us today for the Satellite Book Club Seminar Series. This is session number 48. I hope everybody's doing well. We got a great presentation today. Satellite data in the Graphical Forecast Editor, something I'm very looking forward to hearing about. Margaret Curtis, a meteorologist from the Gray, Maine Weather Forecast Office, is joining us. Just a few reminders before we get started today that the session is being recorded and there will be an opportunity for Q&A after the presentation. Please post your questions in the chat and we will field them in the order they are asked. We are also looking for future presenters, and if you have an application you'd like to share with the field, please get in touch with us. Let us know. We'd love to have you. The training team can also help create training materials that may be unavailable. Brian Mata, Office of the Chief Learning Officer, has information or questions regarding that. Thank you to the Tower S team, particularly Kashad Bowman, the Office of the Chief Learning Officer, the GOSAR and JPSS programs for their support of the Satellite Book Club. There's a lot of behind the scenes work that goes on to deliver these seminars every week, and we really appreciate that. Without further ado, I'd like to introduce Margaret Curtis, who's a meteorologist at the Weather Service office in Gray, Maine, where she has been the GFE and AWIPS focal point for the past 10 years, has developed numerous tools for GFE spanning a wide variety of topics, and has been involved in many national and regional programs, including the Grid Image Maker, Enhanced Hazardous Weather Outlook, and is currently serving on the National Forecast Builder team. We will have a moderator facilitator following Margaret's presentation, but we're a little unsure who that's going to be yet because of some timing issues. So I'll introduce our facilitator after Margaret's presentation. Margaret, take it away. Thank you for being with us.
All right, well, thanks for having me. Good morning, everyone. I think I can get away with my signature good morning. Presumably some of you are in Pacific time. I'm going to be giving a review of satellites in GFE, starting with what is GFE, what satellite products are available, and some tools, and really a lot of time that we can devote to discussing about the future, because there's lots of things that we could add to this setup. So what is GFE? I'm guessing a lot of you on this call live and breathe this software every day, but a few of you may not. It is the Graphical Forecast Editor. That's what the Weather Forecast offices, as well as some of the national centers, TAF-B, the Storm Surge Unit, WPC, OPC, use to produce our graded forecasts. So that's how we live and breathe the forecast. We have two different types of things that we use to work on our grids. Smart Tool, that's something that's a little more basic, maybe only modifies a single element, or a procedure, which might use multiple tools, multiple different things to integrate in and adjust the grids. So this is my view from my forecast desk here in Maine, although the same principle applies no matter what forecast office or center you're working at. Here I've got my low temperatures, and yes, for those of you from the south, we are really still running into the 20s and 30s right now. This was just last week. So if we look at a closer view, you'll see that there are individual pixels. WFO standard operates at 2.5 kilometer resolution. For the national centers and OCONUS sites, that's a little bit bigger, either 3, 5, or 6 kilometers. But again, the principle is the same. So for each one of these individual pixels, say here we have a low temperature of 27, that will correspond to an individual point in the National Digital Forecast Database and on the weather.gov site. So if you were headed up Mount Washington, New Hampshire, you'd find a low of 27 and windy, which is pretty typical for this time of year. So what's available in GFE for satellites? First of all, GFE has a wide variety of data sources. We've got the NAM, the GFS, the HER. Basically, if you can name it in terms of a model, we get it into GFE and can use it in our forecast. Right now, we do have an observed database that's based on surface observations, both METARs and mesonets, and we have a satellite menu. Currently, that satellite menu at baseline has all 16 channels of goes east and goes west. For the eastern offices, goes east, western offices, goes west, and I'm hoping someone on this call can confirm for me, but I suspect if your GFE domain overlaps both satellites out in the central part of the country, you should be able to have access to both. We don't have any polar orbiting satellites available right now as part of the AWIPS baseline. However, I'll discuss further on some ways we could go about adding those types of things. So here's the basic 16 GOES ABI channels, channels 1 through 16. One thing that I do like is that this has been set up so that the color curves match the standard color curves that forecasters are used to in D2D. So just by glancing at this, I know that this is a water vapor channel here with that characteristic dry moist color scale. We've got the visible channels, veggies, IR, and going on all the way up through 16. Again, our whole world is at 2.5 kilometer grid. That means that in the case of these satellites, for some of the channels, the resolution is actually decreasing, going from a 1 kilometer native satellite resolution to a 2.5 kilometer grid. And in some cases, it's going the other way for the 4 kilometer native resolution down to a 2.5 kilometer grid. So the most obvious use for the satellite data is for sky grids. I have to forecast sky cover every hour through the forecast. And so one way we can do that is using the Sky from Satellite Smart Tool. I should say for WFOs or National Centers Online, everything that I'm talking about in this presentation is either in the AWIPS baseline or available right now on the SCP. So you can run this no matter where you are. But here's a look at the satellite image. You can maybe see the East Coast lined up. I've got a variety of clouds over Maine and New Hampshire. And what I want to do is take a look at what that looks like in GFE. Well, in GFE, what we see is the actual brightness temperature value in Celsius. So we've got some -31 colder cloud tops through the north, some lower cloud tops, and possibly even some clear skies. So what the Sky from Satellite tool does is goes through and lets you pick a threshold for clear and a threshold for cloudy and create your sky grid from that. So here's two different examples of how that might look. Here at the same time, in this case, I was doing this on the overnight, so I was using one of the IR temperature channels. We can take a look. The clear threshold was set to 0. So we have this blue area is the resulting sky grid of clear sky. The gray area is the resulting sky grid of 100% cloud cover and the variation in between. That might be what I like, or I can tweak it a little bit. Here I set the threshold to cloudy down to -10, and then you can see you get a little bit more detail in this portion of northern New Hampshire where the sky cover is a little bit more borderline. So you can use the temperature thresholds. And again, this works for both the IR channels as well as the visible and even the FOD product, the difference between the IR and near IR channels. But the one thing that you do need to watch is that this threshold will change, particularly if you're trying to use it right near sunrise or sunset. Maybe you're fading in and out of whether that visible band is really useful. So you do need to take a look at what your satellite grids show and not just blindly run the tool based on the default. So another great use for the satellite data that we like to do all the time is use that same methodology that we use to produce the sky grids to produce the weather grids, the coverage for fog. Now, I will have a slight disclaimer here that the minute I started prepping this presentation, of course, all fog disappeared completely from my area. I generally like to use this tool when we have a nice valley fog set up, a night that's maybe completely clear and you can see the valleys all etched out in the satellite image. But for this example, I took what I could get. Again, here I'm looking at these warmer temperatures on the IR, which might be representative of lower clouds. I can assign that a type of fog, patchy area, widespread, or dense fog. And then I get the resulting grid in GFE. So now I've got this little red squiggle. This is fog, exactly outlining where my brightness temperatures met my criteria. So that tool is also available on the SCP for use. So I reviewed some things that we are doing with the GOES data, which is the main data source that's baselined into GFE. But what about all of the other satellites? Well, it's possible. This is some work that I did in conjunction with the Ocean Prediction Center to get the advanced scatterometer data into GFE. This is a polar orbiting satellite. You get 2 passes a day descending. You can see here on the left is what we see natively in GFE. You've got 1 satellite pass, and you can a little bit see this line where it stitches into the two satellites together, and it measures the wind over the ocean waters. Now, this is a great data source because it does what satellites do so well, which is fill in where we have data voids. So now instead of having 3 buoys in my waters, I have a big area of winds. So we're able to take that data and put it in and create a new database in GFE. So here's the analyzed values of wind over the waters derived from the ASCAT scatterometer pass. So this is great, but you may notice this cuts off at the edge. That's what the satellite does when it interacts with land. However, as a forecaster, I still need to fill in those areas between the edge of the satellite and the edge of the land. I can't just leave a hole in my forecast. So one way we can also approach that is to then merge this data set with others. Here, I've merged our existing observed data set, which over land includes the ASOS, AWOS, and Mesonet sites, with this satellite-based ocean-derived winds, and here we get a total picture of what the winds are. So that is available for offices to use on the SCP. If you are a WFO with a fairly small marine responsibility, you do find that the satellite only goes over you about once or twice a day, so there's a limited number of hours. But for OCONUS sites or national centers, areas with a larger marine responsibility, it's certainly a big improvement in data coverage over the ocean. So what products could we add? Well, I started going through the satellite menu to think about this, and really there's a ton. I think there's a lot of room for growth in the GOES derived products. When you think of things like the cloud mask, the cloud top height, fog products, we're producing aviation grids, which requires us to look at IFR probability. We're looking at the cloud base. And there are other derived products, things like CAPE, that we may be able to use to say, okay, where's the CAPE high enough for thunderstorms? The entire polar orbiting suite is something to get looked at. Altimeters for wave height would again fill that in over the ocean. And there's also some opportunities for snow cover or ice cover, particularly in the Great Lakes. We don't want to be producing wave grids in winter where there's ice cover, so we need an ice analysis. These are all opportunities from satellite. And just to look at what that might look at, I think the cloud mask is really doing what our Sky from Satellite tool does, just more completely. This is the look at clear versus cloudy, and I should say this is a different day than the one in the Sky from Satellite example, so that's why you see a slightly different value in here. Cloud top height, this is an open question to the satellite community. I noticed there's a cloud top height product. I noticed there's some cloud thickness products. My immediate question is, gee, if I have the height and the thickness, could we put that together and work on our cloud-based primary, which is one of our mandatory aviation grids? Fog is another huge one. We do have the night fog product. I should say I am creating this in the tool. So the night fog is just the 10.3 minus the 3.9 micron channel. So one option in the fog tool is to just subtract those. And that really gets at one way we could work at adding more satellite data to GFE. We have these 16 native ABI channels, so any combinations of them are possible. Another option is combinations with the RGB. I'm a huge fan of this time microphysics RGB. I know a lot of forecasters really like it. So this is one where while we don't technically get the RGB processed into GFE, we do get the individual red, green, and blue channels. So there is some potential to take that and convert it to a value and convert it to an analysis of the current, say, fog coverage. So what's stopping the progress? Other than time, perpetually. But the big thing is the file formats. In GFE, it's pretty easy to add another grid type. Pretty much anything you can send me on a regular grid, I can ingest immediately into GFE. However, his satellite is buried pretty deeply in the depths, so it's not a matter of just adding something. In fact, when GOES 16 launched, we lost satellite data in GFE for over 2 years until it was able to be reincorporated into the baseline due to the differing file types. And the other thing is that, of course, satellite is wonderful for their current observations, but we do spend more time on the forecast in GFE, so we do spend more time looking beyond hour 0. And with that, I'd like to open it up to discussion. I'd be interested to hear what other people are using in terms of satellite data in GFE, or where others would like to see this move.
All right, thank you, Margaret. And I'd like to introduce our facilitator now. Fran Acorn is the Senior Developmental Meteorologist at the Ocean Prediction Center.
Hello, everyone. Thanks, Margaret. And we wanted to encourage everyone to stick around and ask questions. You can put them right there in the or let us know if you want to ask a question verbally. Couple of housekeeping things. We do have a survey that will be posted in the chat. We'd like you to take at the end of this. And then we wanted to let you know that next week, so Thursday the 13th at 12 Eastern, Carl Jones, who's a meteorologist at Grand Forks WFO, and William Straka from SIMS are going to be discussing applying satellite data to detect river flooding. So if you have any questions about upcoming things or any questions for Tower S team at all, please contact Lee Byerly, reach out to Kashad Bowman. They can help you with questions on this, configuring satellite products, all of those things, and there will be an email to follow from the Tower S team. But I see we have a bunch of questions already starting off in the chat. So let's start with Dan's. Do you need to use model forecast info to populate the cloud cover forecast grids? If yes, is RH as a proxy for clouds or explicit cloud outputs from the higher res models, or do you use something else?
Yeah, so I just answered that in the chat, but basically it depends on the model. There's a few models, most notably the Canadian, that come in with a total cloud cover TCC field, but for most of them, we're calculating based on RH in a variety of different ways. And if you are interested in getting into the weeds of what RH levels and how, that code and information is available, so feel free to send me a message.
All right. The next one we've got is Bill Schoberg. In regards to polar, you can use the polar to extend products polar data to extend them poleward, but it also works better obviously when there's more passes. So so also higher resolution can help define the smaller scale features. Bill, did you want to talk more about that, or?
I may be stating the obvious, but as you go poleward, you get more polar passes. They cover more areas, and then the higher resolution, you can not only spot smaller scale features sooner that might become larger scale features, but also you can work with GOES to track those smaller scale features in time. So you spot them in the polar data, and then you track them in time with the geo data.
Yeah, absolutely. Certainly for the Alaska offices, the polar pass would be much frequency. I should say we're at 45 north, so we only get 2 passes a day. In terms of the time resolution, that's something I forgot to mention within it, but in GFE, we're always operating in 1 hour time steps. So certainly high resolution satellite data is very valuable as a forecast, but in terms of something that can go into the forecast editor, we're limited in the time resolution to hourly.
Yeah, and don't forget you have 2 polar satellites. You have SUMI NPP and NOAA 20. So you get 4 passes.
True.
Yeah, it's just 2 per satellite, I think. So
yeah,
for like
2 per satellite.
Yeah. Edward Kern was asking about if the tools were Python 3 compliant, and Margaret already answered that. Go
Yep,
ahead.
I have converted them to Python 3. That said, we are not on Python 3 here yet, so I cannot 180% guarantee, but they've been through the conversion process.
All right, from Frank Alsheimer, how are you blending the current data given by the satellite tools into the forecast data the following hour?
I think that varies a lot by forecaster. I know personally, I tend to put the analysis in and then usually use the interpolate feature towards whatever mesoscale model I feel is working best. But there's probably as many answers for that as there are people doing it.
All right. From Caitlin Rutt, just a clarification, all the tools are on the SCP and they are available to all offices, correct?
Yes, that's correct. They're all on the SCP. If you are in Western region, you'll need to go through and change the word east to the word west, and that is in the instructions. And I should say not in Western region, but in the territory of goes west.
All right. From Bill Line, is Eastern region using the National Blend of Models to populate grids now?
Eastern region is, I'm not gonna, don't quote me on whether we are or not. It is in process. I'm trying to remember if that was last month or next month that it was officially taking place. But yes, certainly soon, if not today.
Yeah, if not now, soon. Okay. All right, and actually I see the response right now from Frank Alsheimer that they're experimenting with NBM now across the offices for days 4 to 7, but it's office by office for the first 3 days. Right. I'm gonna go ahead and if you actually had a tool in AWIPS or a method in GFE to bring in any of the data, would that make this much easier, setting these things up?
Yes, absolutely. The way we handle models and the way we handle satellite data are unfortunately completely different. With models, if I get a new model, I can go through and say, fill out some XMLs with the model's name, the variables I want to look at, and get it going. The satellite initialization products is buried deep down in the code, and it actually requires a change to the AWIPS baseline. So I actually requested GOES 16 get added to GFE the day after the satellite launched. And as I said, it took well over 2 years for it to be able to get implemented into the field. So I think that's one of the biggest areas for improvement is if we could get a change so that we could add all of these satellite fields rather than requesting them individually and waiting.
Yeah, because, or even with the RGBs, and maybe the Towers S people can tell me, because I know that D2D is doing those RGBs on the fly. Do we have access to those algorithms so that if we were trying to code it in Python, because all of the GFEs in Python, is that even possible?
Yeah, and Fran, you're getting a great point. If we have access to those algorithms, because we have the native 16 channels of data, we could, of course, recalculate everything within the GFE framework.
Yeah, I don't know whether that's something that we have access to in the D2D configs or if it's buried in code somewhere. So, all right. What one data set, if you could have anything right now, would you ask for?
I can't say all of them.
No, all of them.
I would lean towards the RGB, that nighttime microphysics. I feel like is one of the most valuable of the GOES derived parameters. Certainly one I turn to most frequently, but I would imagine this would vary a lot by office and by area of the country.
All right, I did get Monica Bozeman just responded to my answer about the RGBs, and they're in the in the configs for the menus.
Oh, yeah. Okay.
Or it's where the RGB calculations are. So that's where we steal them from.
We can dig them out then.
Yes. Yeah, they're not hidden. All right. I will say that, you know, so Margaret worked with us as a on a detail for a year, and that ASCAT tool was one of the ones that we got from her time with us, and it's been very helpful to be able to have so many more observations over the ocean and get that initialization much closer to reality, at least twice a day.
And one step that can be taken or maybe being taken is that, of course, as we improve these initializations, that offers the ability to improve the bias correction. So if you're merging the ASCAT into the OBS database, then as we're running our 14-day bias correction, which is the standard for WFOs, at least in Eastern region, all of those additional observations are being incorporated. So another opportunity would be to add the initialized satellite into the OBS database for sky cover, which would again assist with the bias correction.
Yeah, and the altimeter wave heights and even the altimeter wind speeds, although they're just one number along the swath, it's still so much better than nothing. And I understand it at FO with a small area of water that you may not get a hit very often, but at least in the open ocean, we've got, I think, 6 altimeters right now and another one that is in validation. So we're actually hoping to get some of that into our GFE as well.
I see a question from Linda about ASCAT. She pointed out that it's getting it in from a remote server and that there's a delay in the data. And since we do get it from the SBN, could we improve the lag time? The answer is actually not by much. Most of that lag time is actually in the satellite data getting to us. Typically, ASCAT arrives around, Fran, you can correct me here, but around 90 minutes is what I usually see after its observed time. Because of the data formats and file processing issues, yes, our ASCAT tool is getting a copy that Fran is creating of the merged satellites from OPC, but most of that delay is the 90-minute wait for the data to come in. It's kind of a negligible portion for when we're waiting to piece it together and send it back out.
And the files that come over the SBN are in what they call an MGDR Lite format, but we can read that with Python. So the hard part with that is actually writing it back to a grid. But if it's something that we can just use them as point data and just read the lat longs and the values, that might be something that we could get it on a trigger.
Yeah, to any of the satellite folks listening, I would say the bottom line is that anything that you can send out to us on a regular grid in GRIB2 or in NetCDF just gives us so many more options, so much easier to use the data, at least within the Graphical Forecast Editor environment.
All right. Do we have any other questions? Anyone?
Yeah, this is Jordan. I have a couple questions. We've had this discussion about the RGBs, and I guess a little curious about how you would envision incorporating data from an RGB, because it's not quite as simple. There's multiple components, and would like your thoughts on how you would convert the RGB into some element in the GFE.
I would envision it as being similar to the fog product or the fog grids that we're already creating. So I know when I look at that RGB, that sort of light blue color represents the fog. So I think we'd need to find similar to a brightness temperature mapping to the sky cover, we'd need to find a color and RGB value or value range that we could map to fog.
Yeah, all of those tools are in Python. So we'd have to be able to read it in, use NumPy to do the calculations, and then it's translating what would be in the color map in D2D as the thing that you're looking for and making a mask on that, and then applying whatever value it is. Whether it's that mask is, okay, this is where there's fog. Okay, now let me go in my weather grids and have the tool apply fog there. That's how it would sort of work.
So I guess a follow-on related question then is, how do you deal with the artifacts? I think you had a slide in the presentation that I think it was the cloud mask, and it seemed like there was some issues related to coastlines, whether it was the Finger Lakes or I believe it was Lake Ontario, that seemed to have a cloud devoid region on either side of the lake-land interface. So as you bring that into GFE, is that a concern for you, or are forecasters accustomed to dealing with those kind of imagery artifacts in the finalization process of the grid?
I think I would say yes. I can re-share this monitor too so everyone can see what we're talking about. So that's a great observation here. It looks like the Finger Lakes and Lake Ontario are masked out in this product. I'm not familiar enough with how this product gets created to know exactly why that is. In terms of whether forecasters could take it, it might be an in either or type thing. It may be that some times of the day or year it works great. Maybe the Binghamton office doesn't like it, but the Boston office thinks it's great. So it'd have to be a matter of trial and error.
Also, if the forecasters have been trained to look for that, if they know cloud masks, sometimes I get artifacts over the lakes, and you're really only using the one image at the start. It's not like you have to do it out for 7 days. It would be pretty simple to paint it out with some of your GFE tools.
And then
they'd have to know to look for it and address it.
Okay. And then one other question that I have goes back to, there was a slide that listed the possible products and the applications, the grids that they applied to. I was hoping maybe you could provide a little bit, yes, this one, a little bit more detail. I mean, some of them are, I think you demonstrated, for example, how fog contributes to the weather grid, cloud mass contributes to the sky grid. But I'm wondering if you could provide a little more specificity for your aviation grids, for other grids you may have, how things like precipitable water and CAPE would translate into a grid that you are trying to forecast for.
Well, currently we do have precipitable water and CAPE both available within the GFE framework. Most of the data comes from modeled, so either per GFS, whatever. CAPE we usually use for thunderstorm potential to outline an area, say let's put slight chance of thunder wherever the CAPE is over 500. Similarly, precipitable water, let's put heavy rain, showers with heavy rain or rain plus over an area where the precipitable water is over 2 inches or over the climatological value. The translation of IFR probability to aviation, I think, would be a little more interesting at this point. Right now we do have aviation grids. For the weather, we've moved towards a conditional probability type where we have these pot grids, which is the essentially conditional probability of rain, conditional probability of snow. Right now, we don't have a true conditional probability for visibility or ceiling, but I could foresee a scenario where that IFR probability is incorporated into conditional probability of ceiling or conditional probability of low visibility.
Okay, thanks. And then I guess going back to precipitable water and CAPE, I certainly understand how those can feed into, I guess it's probably additional smart tools that go into the probability, but the GOES derived products are current. So I know Frank already asked that question about how you're blending it in, but could you talk a little bit more about how you're, extending that value out further? Because, I mean, at the 0 time, conceivably, you would either have a thunderstorm or you wouldn't.
That's true, and I can see less use for those two for the 0 hour than we do for the future. But I do always think it's important to be aware of where you're initializing, and certainly just having an idea of what's going on now. Whether that's, there is a tool, for example, called Extrapolate. So maybe if you have an atmospheric river plume and you're expecting it to move east at 25 knots over the next 6 hours, you can in fact take that initialization and advect it through your domain. And that's another way of taking those initial values and moving them forward and using them more into the forecast.
And then, yeah, Ross, I was just going to ask this last question here is
100%.
how about lightning?
Yeah, lightning would be great.
Absolutely.
I mean, lightning activity level is one of the grids that's produced. We use it for the fire program, perhaps most obviously, but we actually also include it in all of our recreational products just for folks who may be sitting out on the lake, hopefully not sitting out on the lake in a thunderstorm. So lightning, and that's lightning flash density is already in a gridded format, so that seems like most easy to translate.
That's been on OPC's to-do list, is to do it off of the lightning density grids and off the gridded version that comes from those R series, but then also to be grabbing some of those parameters from things like the HER and models that have that too.
Darren is saying that there's already an app on the SCP doing that. You'll have to let me know which one that is. I know we have a couple of the different lightning apps, but I don't know that I have it set up as a grid right now. Of course, summer is coming.
All right, from Alex Ferguson on the subject of probability of type grids. Some regions or offices are using probability of temperature grids for fog. Do you use GFE tools to edit the POT fog grids, or do you edit the weather grid directly?
I think I have both. The version right now that's on the SCP applies to the weather grid, but certainly if you want it to do the pot fog grid, I've modified most of our other tools to handle the pot fog grid. So I can put that on a sticky note. If I don't have that version on the SCP, I will happily add it.
Oh, and Darren added the tool, it's called LTG. All right. Fazoy Syed, are you using other satellite data products providing ocean surface winds besides ASCAT?
Fran, I would turn that one to you. ASCAT is the only one that I have running here, and certainly, as you know, that took a lot of configuration, so I suspect that's what's limiting us there.
Yeah, the ASCAT A and B, we did just lose, I think we just lost SCAT-SAT, if I'm remembering right. But
Yep.
then the wind speeds out of the altimeters is one of the things we were going to come to. Oh yeah, the Answer 2 has some also. And I want to say, yeah, we haven't used those in GFE yet, but we do have them configured in D2D for the forecasters to look at. Okay, from Matt Neal in Monterey, an install question for the West Coast office only. Seeing the goes east in GFE, what needs to be updating to put it in goes west? Is it a server config file, or you said it was in the instructions, right?
Well, it's in the instructions for changing my tool, but you should be baselined in the server config for which satellite. You can send me an email. I'd have to be looking into the config file. But the existence of satellite data in GFE is a baseline AWIPS problem. So you can call NCF and open a ticket if your office is not getting satellite data at all. The additional tools and the additional ASCAT are the SCP tools that I maintain.
All right. Any more questions? Oh, wait, just saw one about interest. Would there be interest in getting the advective layered precipitable water product in GFE? Assuming the data comes in via NetCDF or Grid2 formats. It's derived from polar orbiters and can be found at that 0 location.
Yeah, I think Fran and I had this discussion yesterday. If you offer forecasters data, the answer is going to be yes.
Yeah, yeah. And just looking at it, you know what, I feel like we might be getting this one at OPC, but not in our GFE right now, just in D2D or anyways.
The chat sounds like Salt Lake is not getting Goes West either, so there may be a larger issue there. I just worked with Pittsburgh. We fixed their issue, but they're an east site, so we'll have to work on that.
Yeah, and consider opening the tickets with NCF, especially if it's more than one office. It might be something for a bunch of them.
Yeah, it is, as I said, it is baseline, so feel free to call NCF.
All right, anything else? Okay, well, I just want to thank you, Margaret, for speaking today. And I believe that I am handing it back over to whoever.
Yep. Yep. You're handing it to me, Fran. Thank you so much. And thank you, Margaret, again for your presentation today. Fantastic. And a good discussion. And quite frankly, a discussion I think we need to talk a lot more about, and specifically in terms of the level 2 products, because I think there's some things that we're thresholding that perhaps there's products out there that would do a better job at that. And if there's not, there's opportunities to improve those products. So I think there's a lot of good applications to deliver the data all the way into GFE. And this is a topic that I think we're going to want to readdress and hopefully enlighten into our field as well, based on the discussion that we had today. So I hope you're going to be able to join us next week, Thursday, May 13th, again at 12 noon, for Carl Jones and William Straka, going to be discussing applying satellite data to detect river flooding. And also, if you have any questions related to the Satellite Book Club or the configuration of satellite products, you can always get in touch with our Tower S team, John Evans, Lee Byerly, Kashad Bowman, or through the NWS chat. With that, I hope everybody's staying well and that you'll join us next week. Take care.
Bye, everyone.
Thanks.